factor form. If 2 is a factor, or a solution, then x minus 2 has to be one of the factors, because if you put a 2 into here, it would make it equal to 0. And then what you have left is these coefficients for the quadratic. X squared minus 2x minus 15. And multiply this times this to make sure that you get back to here. Do it right now. But that's how you synthetically divide. Beyond a quadratic, we have no means to factor. And this is the only way to do it. Synthetically divide. There's a couple of ways to do it, but this is the way we're going to do it. And now once you have this, now you can use quadratic formula, you can do completing the square, you can try to factor it. Any of those ways to finish factoring the problem. Does this make any sense, Jesus? Have you seen this before? Do you like it or no?
It's okay.
Okay, well let's practice a little bit. Let's do 2 or 3, then you'll get it. You know what I'm saying? It's just it's a technique, that's all it is. Okay? And what's neat about it is like you can keep on doing synthetic division. You don't have to use quadratic formula here. You can just keep on synthetically dividing, which I'm going to do now. I'm going to try the next one on my list, which is 3. Because if 3 is a factor of this thing, negative 3 is a factor of this thing, then it should be a factor of what's left. Does that make sense? So I'm going to write negative 3, and I'm going to try to synthetically divide this again. And I get, bring down the 1, negative 3 times 1 is negative 3. Add these two together, and I get negative 5. Negative 3 times negative 5 is a positive 15. And it worked again. We've just synthetically divided twice to get all the factors out of this cubic. And here's how you'd write it. Since this is a solution, again you write it as x minus 2. This is a solution, so you write it as x plus 3. And then this is what's left over, so you would just write it like that. X minus 5. This cubic, using synthetic division, factors to this. Again, if you want to work on a couple of those, let's do it. It doesn't really come up a lot, but it's something where if you don't have a calculator, if you just need to try to factor something, it's a way to do it. Okay? So you've seen it now. If you've never seen it before, if you'd like to practice it, let's do it. If you've seen it already, it's kind of a good. Is it coming back? If you've seen it before,
Yeah.
Jesse, is this coming back? Okay, good. Yes. Okay, good. All right. So then we have this top thing factored, and we can write it all nice and factored. Limit as x approaches 2 of x minus 2, x plus 3, x minus 5. Now what's this denominator? What do we call that? What's that called? Difference of squares. So how can you factor that? How can you factor the difference of squares? What's that equal to, Rafi? Yeah? This? What is it?
X plus 2x.
Yeah? So now you have this thing all factored out. And I want to evaluate the limit as x approaches 2. Well, from this point, these will cancel out. Leaving you with the limit as x approaches 2 of x plus 3 times x minus 5 over x plus 2. Oh, gee willikers, we still have a denominator. We can't just directly substitute in. You can. You can? You can? Just directly substitute in now?
Yeah.
What am I evaluating? X equals what? As x approaches what?
2.
Can I just directly do it? What do we get? Evaluate the limit. We get negative 15 over 4. What does that mean about this problem? Add x equals 2. Give me some information, Estella, at x equals 2 about this function. Yeah, the limit exists. The limit exists, and it has a value. What else do we know about this function at x equals 2? Huh?
That's the limit.
That is a limit. Anything else? Did we discover? It is a removable discontinuity. Why is there even a discontinuity at x equals 2? Yeah, again, the function value, f of 2 equals what? F of 2, yeah, undefined. F of 2 is undefined. The function does not have a value in 2. The limit exists, and it's equal to negative 15 over 4. Since the limit does not equal the function value, the function is not continuous at x equals 2. What type of discontinuity? It's removable because the function value exists. It is approaching the same value, it's just missing one point. What can you say about the limit as x approaches negative 2? What can you say about the limit as x approaches negative 2? How are you figuring this out so mathematically?
Well, I plug it into the calculator and I was looking at the table, and it goes from negative infinity to infinity.
Is that what the graph shows too? Of either this or this? Yes, Eleanor.
Because then you have the top of it, the numerator becomes a value, but the denominator is still 0.
Does that make sense? This isn't, if you plug in either to this one or this thing, if I wanted to evaluate it at negative 2, at negative 2, this would be negative 2 plus 3, negative 2 minus 5, negative 2 plus 2, which is 1 times negative 7 is negative 7 over 0. It's not indeterminate form. That is a vertical asymptote. Does that make sense? And you can do that algebraically just by crunching those numbers. Okay? How do we like that? Was that fun or no? Great. Great. This will be even more fun. We'll like it. In your groups, just like 41, see if you can answer this top problem. Find a value for A and do it without a calculator at all. Yeah. No, not really. Yeah, it's just kind of a tool. I haven't seen it on any old, maybe way back in the day, but it's more, they've been testing more, it's a calculus test, so they test the calculus issues where synthetic division is more of a, it's a pre-calculus concept. But for you, you should know it. You should know it. Well, might as well. Because once you do 2 or 3 problems, what's that? Yeah, let me start. Let me get all this out. Do the top one. We're doing this one. Do this one up here, guys. For you, you should know. Why? Because when you're designing your fruit, you need to know this to simplify the math. You should know it. Yeah, is it an end-all, be-all?